Ladies and gentlemen, welcome to the final episode of Graph Theory, episode number 19, 8 months after the release of the very first episode. Wow, it's been a long time. As usual with all my algorithm series, I like to create a wrap-up episode like this one, where we will very quickly run through all the things we've covered so far, just to have, a good reminder of what we've been through. Unfortunately, over the course of these 19 episodes, I have made quite a few mistakes here and there, so what I will also do in this episode is to point them out and make sure, you know that the corrections have been made and how to find them. Of course, I will end off this episode by giving credit to all the people who have helped me along this process. So yeah, these are essentially the 3 big things I want to do for today's episode. So yeah, that's essentially what we're gonna do today. Hello and welcome, for the very last time, to Graph Theory. What we're gonna do first is to just run through all the things we've covered so far. So without any further ado, let's jump right in. For the first 3 episodes in this series that came out, nearly a year ago, we took a look at some basic concepts about graphs. Like what a graph actually is, what are some types of patterns we can see in graphs, as well as what are the different strategies we can use to represent the contents of a graph in memory. Then from episodes 4 through to 6, we looked at the most basic algorithm you could run on a graph, that is breadth first search and depth first search, with the objective of generating a spanning tree. From episodes 7 through to 9, we now actually stepped up our game a little to look at minimum spanning trees. So there are just a spanning tree, but we want edge weights to be minimized. We looked at 4 algorithms to do this: Prim's algorithm, Kruskal's algorithm, Borufka's algorithm, as well as the reverse delete algorithm. This of course beautifully highlights how we can actually use many different ways to solve the same problem. For episodes 10 and 11, we looked at Dijkstra's algorithm, as well as the Bellman-Ford algorithm, 2 ways to approach the single source shortest path problem. We saw how Dijkstra's algorithm was faster, but would fail on negative edge weights, whereas Bellman-Ford algorithm would actually do more work, but work around that problem. For episodes 12 through to 15, we took a look at topological sorting. We first tried to understand what a topological sorting even is. Then we looked at Kant's algorithm as well as Tarjan's toposort algorithm to see how this problem can be solved. We then tried to link it all back to pathfinding. For episode 16, we looked at the all-pair shortest path problem, using Floyd-Warshall's algorithm as a solution. For episode 17, we took a short break from looking at graph algorithms by just turning our attention to dynamic programming, which is, a different programming technique that could save you some time. We applied this in episode 18 for the traveling salesman problem. We took a close look at one of the classic hard problems in computer science, and we figured out how to actually solve it relatively quicker using dynamic programming. And that brings us right back here to the conclusion of the entire series. Now, I have to admit, this was a pretty difficult series to create, mainly because a lot of it is pretty abstract concepts that I realized I haven't fully internalized from my own school days, and what that means is trying to present it in an easy manner to you isn't that easy to do. And it shows in the form of the mistakes that I have been making throughout this entire series. In fact, I've taken note of 5 different mistakes here that I have already fixed, and I'll just very quickly run through them so you're aware that they exist. Of course, like I said, if more errors come up, this list will have to get longer, but this video is already up, so I can't do that. As always, keep an eye out on the video description for all the videos I make. Just in case there is an error, I'll write it there. So these are the errors. Firstly, in the breadth first search, I actually made some error in the trace. You want to switch on annotations in the video, you'll see that I have actually sort of patched over the trace. For the depth first search video, I did make a mistake in the trace as well, and I've actually released a separate video to sort of complement it to tell you where the problems are. For the analysis of the breadth first search and depth first search algorithm, well, I made such bad mistakes that I actually pulled the whole video and re-uploaded a fixed version. That is incidentally why if you looked in the playlist, you'll realize that some videos are actually out of order, and that is the reason. So yeah, if you watched it when it just came out, you might not be looking at the latest version anymore, so yeah, just keep an eye out for that. Same deal with the video that covered both Barufka's algorithm as well as the reverse delete algorithm. That was re-uploaded at a later time as well. And the one that was reported to me very recently, that was in Jackstra's algorithm, I actually had one line that had a mistake in the pseudocode itself. So yeah, there's an annotation that lasts almost the length of the entire video, just covering up this problem. So yeah, when you watch my videos, do leave annotations on. So yeah, take note of the errors I have made. As always, keep your eyes open because I'm not perfect by any stretch of the imagination. So yeah, if you do spot any mistakes, do let me know and I'll try to fix it up as soon as I can. So yeah, that's it. That's it for this 8-month long project. I'm kinda glad it's over because it was kinda stressful at certain points. Of course, having said that, I don't want to claim all credit for this because of course, I had to learn all of this from somewhere. Many of these people are lecturers and teachers who have just, well, covered this material during my university time. So yeah, credit goes to them for helping me understand what on earth is going on with all these different algorithms. And yeah, all I had to do was to actually translate what I had learnt there to what you eventually see on screen. And that is it. Thank you very much for watching this entire series. Thank you for sticking around. But that's all there is. Until next time, you're watching 0612 TV. Thank you very much for watching. If you liked this video, consider checking out the rest of my work on my channel. Alternatively, you may want to check out a playlist of the other videos in this series. If you'd like to show me some monetary support, I am on Patreon. You can find a link to my campaign in the video description. Of course, you can simply like this video or leave a comment. I'll be sure to respond as soon as I can. To keep in touch with my future uploads, do subscribe to this channel. And for even more updates, check out the official Twitter account for this channel at 0612TV. Thank you for your support.